All right, on this, should be able to just look at the names. If you get confused by looking at the names and doing it, then you need to draw pictures. Draw a couple of triangles. Label them and do all that, but we really don't have to on this one. If these two triangles are congruent, name me one pair of segments that are congruent to each other.
Q and R and F and G.
Yep.
So segment QR, segment
FG.
FG. Give me another pair. RP I heard, hold on one second, give me a second. Segment RP is congruent to, don't forget your symbols. Guaranteed when we do the test over this and stuff, you don't have your symbols, it gets marked wrong. RP, right here, you can look right here and just see it. RP's got to be congruent to what segment in the other one?
GK.
GK. Now if you drew your picture
K.
and you labeled all of them, QRP, if you drew your picture and you labeled both the two triangles, you could see which ones would match up. If that helps you, then do it.
Segment QP.
Segment QP, everybody agree with that?
Yeah. Is congruent.
That's supposed to be a P, not an R. Segment QP is congruent to
FK.
segment FK. So in those two triangles, if these were our two triangles, you know which parts have to be the same. So if this segment right here is QR and it's 100 centimeters long, and this segment's FG, then it's got to be 100 centimeters long. Next one, name all the angles. First one, I want to name the first pair of angles with 3 letters. Now, in this case, do we really have to name them with 3 letters? How many letters could we use? Just one. All right, just one. But I want to name the first one with 3 letters. So name me an angle in this first triangle using 3 letters.
QRP.
QRP. That's probably the easiest one, right? QRP, remember, when you're naming these angles, if you're naming them with 3 letters, it starts at one end, goes to the other end. The middle letter is always the vertex. What's it going to be congruent to? Name QRP a different way for me. PRQ, going back the other way, right? Still the same angle. And then the third way to name it would be if we just use one letter. What letter would we use?
R.
Just R. So now let's name the other ones just using one letter.
K.
Angle K. What's angle K got to be congruent to?
R.
Everybody agree with that?
P.
Which one is it?
Oh wait, no, P.
Angle P.
I was thinking K's in the middle.
Angle.
G is congruent to R.
Everybody agree with that?
We already have that.
We already have that one, don't we? That's the same as this first one.
Q is congruent to F.
Angle Q is congruent to angle F. Everybody agree with that one?
Yeah.
So anytime you have two triangles that are congruent to each other, got 3 pairs of segments that you know are the same, 3 pairs of angles that you know are the same. Think that might be important in some things out in the real world?
Yes.
If I'm building a house and I dig the footer for it, first thing I want to make sure is what's true about that footer.
It's even.
Everything's even, right? Now, can I just measure here, and say, oh yeah, those two are the same, then measure here and measure here?
No.
Doesn't work that way, does it? Because you could have a parallelogram where it's leaning one way or the other. And then you go to put your footer in there and you pour your concrete, and then about $10,000 later, you're ripping it back out and pouring in new concrete. Right? So what you can do with that, if I draw that diagonal in that rectangle, and I measure it, and I draw this diagonal and that rectangle, and I measure it, guess what should be true about those two diagonals?
Exactly.
They should be exactly equal. If I look at this triangle right here, does everybody see that triangle?
Yeah.
And I look at this triangle right here, these two, that diagonal and this diagonal, are corresponding sides in those two triangles. So they better be the same length if those two triangles are congruent. And the only way those two triangles can be congruent is if the whole big shape is a rectangle, right? So a lot of times when you're building something, if you want to make sure it's staying square, if you're building a deck, you're setting your posts for a deck or posts for a porch or whatever it is, posts for a barn, and you want to make sure you're staying square, you measure from corner to corner. If you measure from corner to corner and then other corner to other corner, those two distances should be exactly the same. Otherwise, you're not staying square. Otherwise, you're out of square somewhere. Now, if you ever have somebody build something for you and you see some of the people who build some of these buildings and stuff and you think, some of them don't look like they're all that real bright sometimes. I don't know if maybe they know that or not. Huh?
All Amish.
Yeah, sometimes.
That's the only people that have built my barn.
The Amish people know those kind of rules. They actually, they can do that pretty quickly. They got certain set things. And if you build a barn, you know, you got certain set, especially with a barn. That's usually what the Amish people are building. If you build this barn, you know that you have certain setups that you use every time. So if the barn's 30 feet wide by 50 feet long, well, then they know exactly how long that distance right there should be, and they just measure it to make sure it's there. After you do it a couple of times, you just have something to say, okay, make sure that we're corner to corner, we're right. Open up your books to page, what is this one, 243? Does anybody have any questions off of the other two pages? Otherwise, just open up your books to 243. On 243, we had this problem. You're going to want to watch closely on this problem because the homework that we do tonight, a lot of two-column proofs.
Oh.
So everybody loves two-column proofs.
Oh, yeah.
When I go around and check next time, I look at Natalie's and I see that she didn't do all this on the two-column proofs. Got a bunch of dog hair. See that she didn't do this on the two-column proofs. I'm not giving her credit. So next time when you come in, it's not a real long assignment. It's not real short, but it's not super long like the one a couple times ago. But there are 4 or 5 two-column proofs on it. If you don't do the two-column proofs, I don't care how much of the rest of it you do, I'm not giving you credit. Does everybody understand that?
Yeah.
So you gotta do these two-column proofs. Now I'm gonna do this one up here, but if you watch closely when I get to the end of this, I'm gonna show you that the ones that you have to do, nothing near this difficult. All right, and we're gonna learn why today. So we're gonna learn a few rules that'll help out and make it a little simpler than this. How many triangles you see in this picture? 3. Now, this little one right here doesn't look like it can be congruent to any other one, right? So that's not the one we're going to deal with. We're going to deal with this one. Everybody see that triangle?
Yeah.
And then we're going to deal with this one. Sometimes when these triangles overlap, it might be better for you to separate them, split them off from each other, so you can see them a little better. All right? Somebody help me out and let's name these letters here. What's this one?
A, B,
B.
B,
Yeah.
What's this?
G.
A. This?
G.
G. What's this one?
C. Or wait, yeah. C.
D.
D.
So those two triangles look like they might be the same as each other. To show that they're the same as each other, we need to do what we just did on that starter, which is show that all three pairs of sides, or all three sides in this triangle match up to all three sides in that triangle. All three angles in this triangle match up to all three angles in that triangle. Let's go through and see what they gave us here. Segment BE is congruent to segment CE. BE in one of these two triangles?
No.
No, BE is like this little part up here, isn't it?
Yeah.
That's equal to EC, which is also equal to EF, which is also equal to EG. Neither one of those is in either of those two triangles either.
Wait, so, that make CF and BG.
And that's where we're going to next. Back at the start of the year, Wyatt remembers that we did something that looked like this. We had, if this was 5, this was 10. Didn't I send it? No. Sorry, give me 1 second. I marked it, but I must not hit send.
It's a one-sided screen.
So we look at this. Wyatt remembers back at the start of the year we had this.
15.
How long's that whole thing? 15. We used what there?
Adding.
Segment, addition, postulate. Segment, addition, postulate. So Wyatt says segment BG has to be the same length as segment CF, right? So we can mark those. Let's not put 1 mark on them. Let's put 2 on them. So we know those two are congruent. And somewhere in our 2-column proof, we're going to have to use segment addition postulate. Segment addition postulate.
Are you saying we're gonna have to use segment addition postulate for all of these two columns?
Not all of them, but for this one we're going to.
Alright.
Different things in the world, right? Sometimes you use this to prove something, sometimes you gotta go another route to prove. Then we know segment BA is congruent to segment CD. Those two segments in our two triangles?
Yeah.
Yeah, they are, aren't they?
Small lines.
These here, BA, CD. I'm putting circles on them, so I don't have to make so many marks.
No, it would be.
Alright, so now we need to prove this. Side, all three pairs of sides, all three pairs of angles. We now have a pair of sides, another pair of sides. Is that enough to say the two triangles are congruent? No, we still got 4 other pairs of parts, right?
Angle B is.
We got another one here, right? It says segment AF is congruent to segment DG. Is segment AF in one of the two triangles?
Yeah.
No.
It's not, is it? It's like this, where these two, if they overlapped,
It's way
AF is
The little square.
like this part from here to here or something, isn't it? So, but, now Wyatt looks at that and he goes, well, that's the same as the other thing. If this part is the same as that part, so if I start walking here and I walk to F, Gunner starts walking here and he walks to G, then Gunner walks to F, and I walk to G, who walked farther? Neither one, because both of us walked these two distances that are the same, plus what other distance? G to F or F to G. We both walked that same distance, right? So what do you know about the distance from A to G?
It's the same as D to F.
Is that in our two triangles? A to G?
Yeah.
Yeah. How about D to F?
Yeah.
So those two are the same. Let's see, I put 3 marks on those. Now we got another pair of sides, right?
I got a question. Exactly how did you get A and B and C and D?
It was given to us. They told us that those two were the same. So we go down to the next thing. Angle B, is angle B in one of the two triangles?
Yep.
Yeah, it's right here. And we know it's congruent to angle C. So that's a pair of angles. Angle A in one of the two triangles.
Yeah.
So we mark it.
Angle D is too.
Angle D is over there.
Yeah, just 2 angles, does that mean?
Now we got one angle.
Now, we had a theorem last time, right, that said if,
Third angle theorem.
the third angle theorem, good. If these two angles are congruent to these two angles, then what do we know about these pointing angles down here? They gotta be congruent by the third angle theorem. So somewhere in our 2-column proof, we're gonna use the third angle theorem. So what do I know about these two angles?
They're
They're congruent to each other. Is that enough to say the two triangles are congruent?
Yeah.
Now I'm gonna go through this 2-column proof here real quick, because I have it on the slide already.
You might want to just back out of it.
Nah, it'll be alright. Cause I wanna do it like this. So first thing we're gonna say, all those segments were congruent. How did we know all those segments were congruent? Given. Should Gunner miss any of those?
No.
Only if he's talking to Wyatt, well, Wyatt should be listening, right? So we know that that is given to us. Please, again, remember, don't put all your given in one statement, all right? Do I really want to list all this stuff in one statement?
No.
If you do, you're going to be lost. You'll forget about everything else that we just went through and did. Next thing, segment BE is congruent to segment EG. Segment BE plus segment EG equals segment BG. What told us that this plus this equaled the whole thing? Segment addition postulate. So that's what I write out there, segment addition postulate. This plus this equals that whole segment. Next thing, segment BG is congruent to CF. If we look right here, I had those two segments. We had all these congruent up here. Well, if I add those same things together, what should be true about these two?
They're congruent.
They should be congruent. So if I remember, what property did we just use there? When you take something and replace it with something that it's equal to. Substitution, very good. Substitution property. You take something out, put something that it's equal to in its place, you're substituting. What's the reflexive property? Somebody said that. What's the reflexive property again? Anything equals itself. So it's got, when you're saying reflexive property, it's got to be something like AB equals AB. They've got to be exactly the same. Can't be AB equals CD. All right, that's not the reflexive property. It's got to be exactly the same. Next thing we did, segment BA was congruent to segment CD. How did we know that? That was given to us. Next thing we did, segment AF was congruent to DG. How did we know that? That was given again. Now you got to be careful here. Again, was AF and DG in our two triangles that we were trying to prove the same? No, that's where we had me walking from A to F, then I walk FG. Gunner walks D to G, then he walks GF. We walk the same distance, right?
Yeah.
So what do we have to use there again? Segment addition postulate again. AF plus FG has to equal AG, the distance I walked. DG plus FG has to equal DG, or DF, the distance Gunner walked. A reason segment addition postulate. If these two are equal, we just add FG to both of them. That's the same thing, right? If Gunner walked 5 miles for FG, then I walk 5 miles for FG. Well, what do we know about these two then? They got to be congruent. What property did we use again? Substitution. We took out something that was equal to something else and substituted it in its place. Are we finished yet?
No.
We got all the segments. Now we still got to do all the angles. How do we know that angle B was congruent to angle C? It was given. How did we know that angle A was congruent to angle D? It was given. Let me get caught up here. Angle A is congruent to angle D. It was given. And then what was the last thing that we knew? Angle G was congruent to angle F.
And that's.
Now, you can't really name, we said it that way, But can I name this angle right here, angle G? How many letters do we need to use? 3. So what, how could I name it?
BGA.
BGA would work. How could I name this angle?
CFC.
CFD. Make sure you use 3 letters when you need them. Did I have to use 3 letters up here on angle B? No, because if Wyatt says angle B, is anybody going to be confused about which angle he's talking about? No, but if Sam says angle G, could we get confused?
Yeah.
Yeah, because there's an angle that has G as its vertex here, there's an angle that has G as its vertex there. We don't know which angle he's talking about. So those are the ones that we need to name with 3 letters, where the vertex is the middle letter. How did we know that those 2 angles were the same? Third angle theorem. If two pairs of angles of a triangle are congruent, then the third pair of angles of the 2 triangles are congruent. Now do we have enough to say those 2 triangles are congruent?
Yeah.
Make sure when you're naming the triangles, we gotta make sure we match them up. B up here matches up to what in the other triangle?
C.
C. A matches up to
D.
D, so on and so on. Make sure you match them up correctly. A lot of times, like on this one, they already matched them up for us because it was in the proof statement. And our reason for that was because all the corresponding parts were congruent. Then we know the 2 triangles. Now Silas is sitting here looking at this thinking, man, he's going to give me a 0 next time because I can't do 11 steps like that. Well, that's probably a good thing, Silas, because we're not going to do 11 steps. All right? We're going to learn 2 rules today that cut this down to where we could have probably stopped right about there after about 5 steps. And then it's not near as hard. All right? Because all we really needed to know in this, we needed to know this. All right? We needed to know this. And we needed to know that. And that was enough to say that those 2 triangles are congruent. So instead of proving all 6 parts of the 2 triangles match up, we only really need to prove 3 parts. Now, can it just be any 3 parts? No, it's got to be certain parts, and that's where you got to be careful. What's your question, Matt?
Oh, what's the most steps you've ever done?
Oh, I don't know, 18, somewhere in there.
Jeez.
Get it right.
Yeah. There's lots of steps I added. You know, if you're working out some other kind of problem, you might not be writing it out as a 2-column proof like this, but you got to do it. So, okay, I know this, and then I can go to this. Other questions on the homework? So you got to be able to do those 2-column proofs. Hopefully Bobby wasn't writing her name back there the whole time, and she was actually paying a little bit of attention.
No matter how much attention, how much I do for it, I still seem to suck. I don't know, pick up a little bit more.
All right, proving triangles are congruent. Go ahead and write this down. Yes, I do want you to write down the be able to this time. Proving triangles are congruent. That's what we're going to do, and that's what the rest of this chapter is about. Proving triangles congruent. We get to this test, and Sam skips all the 2-column proofs. He will fail the test. That's simple. Because 75% of the test is going to be proving triangles are congruent.
You're gonna give us a lot of time to do that.
Pay attention, I'm telling you that these 2-column proofs that we do today won't be anywhere near as difficult as the ones that we did in the past. So if you pay attention today, you should be fine.
Well, as much I can.
Well, Shaq just when he shot.
Now what we're going to do, we're going to go through, just the notes are real short. I'm going to do a couple of 2-column proofs for you that you're going to write down in your notes. Then we're going to do 2-column proofs on the board up here, and we're going to go around the room. So Natalie's going to come up and she's going to do a statement Then Ian's gonna come up and he's gonna give the reason. Then Hunter's gonna do a statement, then Gunner's gonna give the reason. So Gunner, so that you don't look silly when you get up here, you wanna make sure you're paying close attention when I'm doing them, right?
Oh, yeah.
Still gonna look silly.
Yes.
Well,
I mean, really awkward.
I can't help if you look silly. That's something you gotta talk to your parents about, but, I mean, as far as looking intelligent when you get up here.
I'm adopted.
So what we're gonna cover, proving triangles are congruent. Notice right here. Instead of, when I had it written up here a few minutes ago, I had side, I had all three S's, all three A's. We don't need all of that. So all we really need for this first one is all three pairs of sides. So we can just prove the three pairs of corresponding sides instead of mixing the angles in there with it. What do you think this one stands for?
Side, angle, side.
Side, angle, side. Now this one is a little tougher because with the sides there's really no way you can get them out of order. But with side, angle, side, they got to be in a certain order. In the triangle, they got to be in a certain order. And we'll talk about that when we get to it here in a minute. All right, go ahead and copy this down. So side, angle, side. So instead of proving all 6 pairs of corresponding parts are congruent in the two triangles, all we really need are 3 certain parts. Not just any parts. It can't just be the ones that you pick, because it doesn't work that way. So some mathematician a long time ago figured out, hey, if you prove these 3 parts are the same as these 3 parts, then the 2 triangles are always going to be exactly the same. And the first one that they figured out was if you have a pair of sides, a pair of angles, and a pair of sides. Side, angle, side. So this is called the side, angle, side theorem. Some books have side, angle, side as a postulate instead of a theorem. I'm not sure why. Some books call it a theorem, some books call it a postulate. It doesn't make sense, but
So there's an S after sides and angles. How many angles do you have to have? There's one.
no, that angles means because you have an angle in this triangle and you have an angle in this triangle. So the 2 angles. So it'd be like this angle and this angle. So angles. Couple of the homework problems. They're going to give you a couple of triangles. My triangles don't look like they're the same as each other, but we're going to say that they are. We look at these 2 triangles. To use side, angle, side, looks like segment MP would have to match up to what in the other triangle? LV. So let's say we know MP and LV are the same. All right? And looks like segment PR would have to match up to what? TV. If we know this side is congruent to that side, this segment's congruent to that segment,
Angle P.
then all we need is an angle. And that angle's got to be the included angle. What I mean by included angle, those 2 that you know are congruent, the angle's going to be where they come together at. Can everybody figure that out?
P and V.
So where do these 2 come together at? Angle P
Angle V.
and angle V. It can't be anywhere else to use side, angle, side. It has to be there. All right? Because look at what it does. It goes side, angle, side. It goes directly in order. All right? Can't be anywhere else. So if I gave you let's see, just make up some letters here. and say, I know those two are the same, I know these two are the same, and I know this angle is congruent to that angle. Is that gonna work? No, that does not work, all right? It's got to be in that certain order. It'd have to be, we'd have to know angle A and angle E to be able to say it. All right, so it doesn't work because it's in the wrong order. Even though Gunner's looking at me, he's going, well, it goes side, side.
No, I knew
angle.
the drawing, I just couldn't figure out.
All right, so it doesn't work. Now, usually I'm sort of not a good teacher right here. 'Cause you
Oh.
would have to be the congruent angles. See, I told you, it'll take about 5 minutes.
Did you get it, Sam?
So for these two,
Sam, stop trying.
Right down to the sides.
Write down angle, side, side.
I ain't go to the office yet. I heard that comes
if we know this pair of sides congruent, this pair of angles congruent, this pair of sides congruent, then we know that the two triangles match up perfectly. All right, but it's got to go in that order to be side, angle, side. Now, when we get to side, 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 is it going to be that big a deal where the sides fall out?
No.
Because how many sides does a triangle have? 3. So it's going to be the 3 sides in this one, the 3 sides in the other one. There's no real way you can get that out of order. All right? Go ahead, copy this down, draw this picture. Sorry, I forgot my segment symbols up here, but you need to put them in. Give you a second to do that. Then you're going to write this down. Now, when we take this test next week, if I allow you to use your binders, maybe Sam will find it useful to have some of these 2-column proofs written down in there, right? So make sure that you write down the 2-column proof and do the stuff when I do it up here. Otherwise, you're going to be lost. Also, another thing I'll say, when we do this test, because I know I do this every year when we're in this chapter, one of the 2-column proofs, just about every year, one of the 2-column proofs that you write in your notes is on the test. And then I like to laugh at people when they miss that 2-column proof and say, well, you wrote it right down in your notes. Why didn't you didn't write it down like you were supposed to? Silas, that doesn't sound like me, does it? I'd make fun of you for something like
I
that.
heard about that last year.
My goal is not to be in here next
You were
year.
reading and they're like, that was nuts.
So we just did that problem right before the test in the notes.
I have a question. Will this homework raise my grade up?
Are you gonna do it?
I already did it.
Then can it hurt your grade?
Yeah.
No way, but
Give me
homework
Hurt
is
your
good.
grades.
Isn't that like last test we told us something straight over? Told us to do something like none of us did.
All right, on this.
I did the 7th grade.
How many triangles you see in this picture? 2. I'm not really going to split up these triangles because you can sort of see where they're at right now, right? They don't really, it's not like they overlap each other or anything where they're looking like this and it's sort of hard to tell. So I'm just going to leave them that way, not split them up. What you need to do every time you're doing one of these 2-column proofs, notice, have I drawn my 2 columns down here yet? No, don't start off by doing that. You draw the picture on your paper, and then you mark everything you know. And then we'll go from there, all right? First thing they tell us, segment BC is congruent to segment DA.
How do you know what shape it's going to be?
What do you mean, how do you know what shape?
You said we have to draw that on there, but how
Well,
do
they'll give you the picture.
we didn't say that. You said we had to draw it on.
All right, so segment BC is congruent to segment DA.
Yeah.
Do we have segment BC in this picture?
Yeah.
Is it in one of the 2 triangles?
Yeah.
Yeah, it's in the top triangle. So I mark it congruent to DA. That's a pair of sides. Is that enough to say the 2 triangles are congruent? No, I need sides, angles, and sides, right?
Yeah.
Then they tell us segment BC is parallel to DA.
Yeah, it is.
So these 2 are parallel. Now, every single time you see parallel in a problem, you might want to put this in there. every single time you see parallel in a problem for this chapter and for the rest of the year, this is what I want you to think of. Does anybody remember when we had parallel lines?
Yeah, they went up and down.
We had parallel lines. What was this other line called? Transversal. And when we had a transversal, what did we know about?
Made a Z.
They made a Z. What do we know about those angles that made a Z? They're congruent to each other. They were called alternate interior angles. That's what I want you to write down here. Alternate interior angles. Look for alternate interior angles. About 90% of the time when you see parallel lines, you're going to have those angles that form a Z, and they're going to be alternate interior angles. So what could I use as a transversal in this picture?
The line that cuts the triangle up.
Which one? What's it called?
CA.
CA. So if I use CA as my transversal, got this parallel line, I got that parallel line. Well, when I trace those two, what do I form?
A Z.
A Z. So what do I know about these angles?
They're equal.
They got to be equal to each other. Now be careful. Somebody name this top angle for me.
Angle C or BCD, and then angle BCA or BCA.
Angle BCA
Yeah.
and angle what? CAD. And I know that they're congruent because they're alternate interior angles. Notice over here, it's like writing an English paper. I'm doing a rough draft. All right, this is all I'm doing is a rough draft over here. This is, I put stuff over here, Hunter, so that I remember to put that in my 2-column proof. All right, so that's a pair of angles. Is that enough to say the two triangles are congruent? No, we got a pair of sides, we got a pair of angles. What are we missing? Another pair of sides.
I don't think it's gonna work out because you got a line and then that little, it says angle and then, you know what I'm saying? It's different. It's like not,
Oh, you're thinking it's going to be,
it's the same order.
it's going to be in the wrong order? All right, we'll find out here in a second.
Then it would be CD and a B.
Which, so in this top triangle, let's split off this top triangle.
Okay.
And it'd be AB.
We got this segment and we got this angle. Let's see, that's B, A, C. To ease Gunner's fears here that we're going to write the wrong word on the board, we got a pair of sides, a pair of angles. Which side has to be the side that we're going to pick from this one? Which?
AC.
AC, isn't it? AC, right there. Let's split off the bottom triangle.
It's definitely congruent to A, C.
That's A there, D here, C there. We know this. Oops, didn't write. That was the one marked. This was the one. What's the segment? The
AC.
angle? AC. So we got AC in this triangle, AC in that triangle. Anybody tell me something about AC and AC?
They're exactly congruent.
They're exactly the same. What did we just say earlier? The reflexive property. So we know that this segment right here, this is another thing you're going to look for. Every time you see this, every time Natalie sees this, she sees a picture that looks like this, where the two triangles are touching each other like this, look for reflexive property. They probably share something. They share a segment in this case. So what do I know about segment AC in the top triangle and segment AC in the bottom triangle? They got to be the same. If I tell you segment AC is 50 centimeters long, is it going to change from one triangle to the other?
No.
No, it's the exact same segment. So that's another pair of sides. Is that enough to say the two triangles are congruent?
Yeah.
Yeah, and that's what we're trying to prove is the two triangles. So now we should be able to come over here and write our statements and our reasons. So draw your 2 columns, statements, reasons. What's our first statement going to be? Remember, we're trying to get some kind of pattern here. Side, angle, side, then the triangles. That's all we're doing.
Wouldn't it be segment BC is
Segment BC is congruent to segment DA.
Yeah.
How'd I know that? That was given. Now, to help me out, you don't have to do this if you don't want, but I would suggest it. I know that those two were two sides in our triangle, so guess what I put out in front of this? A little S. S stands for sides. So now I know, hey, I have one of the pairs of parts that we need. We still need the other two. Where do I go to next?
There's BC is, yeah, BCA.
BC is parallel to segment
Yeah.
DA. And that was given. Now, do I put an S out here beside this?
No.
No.
That wasn't saying that they were congruent, that was saying that those were parallel, so that we had to use that. What did knowing that these lines were parallel, these segments were parallel to each other, help us find? Alternate interior angles. Name me the alternate interior angles.
BCA.
BCA, good.
DCA.
DAB. No,
DCA.
I can't see.
DCA. Alright. Yeah, oh no, it's DAC.
What is it?
DAC.
Everybody agree with that? DAC?
No, DCA.
Is it DCA?
No, it's
DAC.
Remember, just go the way you're naming it. If I start at D, then where do I want to go? A, then to C. Got to go in that order. And our reason, and you're going to use this reason a lot, so make sure you write this down and know it. We used it a lot when we were talking about parallel lines. If parallel lines, then what do you know? Alternate interior angles are congruent. I'm sorry. That should be a 3 there. So if the lines are parallel, then we know alternate interior angles are congruent. What do I put out here beside the 3?
Angle.
Put a little A out there. Is that enough to say the two triangles are congruent? No. So we got to go on to something else. Well, we're out of given information. So we got to come up with something on our own. What did we come up with on our own? What was it, Silas? Segment AC, what about it? Congruent to segment AC. How did you know that segment AC was congruent to segment AC? Reflects the property which says what?
Anything equals itself.
Anything equals itself. That's what I want to write down. Anything equals itself. This alternate interior angles one and the reflexive property, you're going to use those as reasons over and over and over again throughout the chapter. Now, Ian, does that mean it's going to be that those two are going to be in every 2-column proof? No, but they're going to be in several of them. What do I put out here beside the 4? Now look at what I have out here. Is that enough to say the two triangles are congruent?
Yeah.
Sometimes we'll have to match the triangles up. This time they already matched them up for us right here. So all we got to write down is triangle ABC is congruent to triangle CDA. Oops. Ignore that stray line going out through there. Now our reason, how did we know that these two triangles were congruent? Side angle side, and that's all you write, SAS.
Just write SAS.
That's fine. So we look down through this. How many points is this going to be worth on the test? 10. It's going to be worth 10 points. Should anybody miss these first 2 points? So that's 2 points. How about these next 2? No, that's 2 more points. That's 4 total. Maybe you have no idea what parallel lines even means. So you miss that one. You miss that. Should anybody miss this one? After you see this a couple of times where these two triangles are stuck together somehow, should you be able to pick out that they share that side right there and say that you're using the reflexive property? Anything equals itself.
Yeah.
I hope so. So that's 2 more points. Already, what grade is that? You got 6 points. 6 out of 10 is what? 60%. Now we look down here at the last one. Should anybody miss this one? No, you shouldn't miss this one because it's right here. It's going to be your last statement every single time. So that's 7 out of 10. Now, right now you shouldn't miss this one because we only got one way to prove two triangles are congruent to each other. So anytime you put the triangles in a statement, your reason right now for the next 2 minutes or so is side angle side. That's the only thing that can go over here. Nothing else can go as a reason why two triangles are congruent to each other. Does everybody understand that?
You say for
For the
the next 2 minutes.
next 2 minutes, because on the next slide we're going to do this,
You can't be besides that.
and then you got two choices, and you're going to have to make a choice. Even then, now you have a 50-50 chance of guessing and putting the right one in there. Okay? All right, draw this. Write that stuff down. SSS. What's it stand for again?
Side,
Side, side. So this time, instead of proving a pair of sides, a pair of angles, and a pair of sides, now we're going to prove a pair of sides, another pair of sides, and another pair of sides. When we were talking about building a barn or something, this is what you would use. Because we have tape measures where we can measure the lengths of the sides, but have you ever seen anybody with a big protractor out there trying to measure the angles when they're building a barn? Doesn't work. Alright? So the way they measure the angles is to say, hey, if I measure these two sides, or all three of these sides, then this angle's got to match up to one of the other angles, and they have to be the same. Now, I don't actually know what the angles are, but I do know that this angle is the same as that other angle, and that's the way I want it to be.
You can get by without knowing the degree of the angle.
Yeah, you don't really need to,
As long as you
keep show that the sides are even. Now, you gotta, again, still be careful, because not just two pairs of sides, it's gotta be that third side in there also, otherwise it won't be a right angle. So we gotta make sure that these match up. Somebody name this first triangle for me so I can fill in the blank down there.
PWG.
PWG. Does it really matter how you name the first triangle? Makes no difference.
Second one the same.
Now you gotta match the second one up. Very good, Bobby. You gotta make sure you match the second one up. And I didn't realize here,
D and P.
let's do this. On your paper there, mark this P out. I didn't mean to use P. Give me another letter.
It's
B.
G or F.
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 Yeah. BMFD.
Alright? So now let's match it up. I use P in both triangles. I don't know how I managed that. P over here looks like it would match up to which one over here?
M.
Everybody agree with him?
Yeah.
MDF.
Now, W looks like it's going to match up to
MFD.
D.
Yeah, what?
So you got to sort of, this is sort of got to like spin and flip around to get it to match up, right?
Yeah.
And then what's G going to match up to?
F.
F. So you have to make sure you match up the two triangles correctly. A lot of times, and on the homework tonight, they'll already have them matched up for you, so you won't have to match them up. Now I say that, and there might be some of the problems where they want you to match them up. Gotta make sure they match up. Mine doesn't look too good because it looks like maybe they could match up a couple different ways. Hopefully they'll show you triangles that are a little more even, not as even as those two. Go ahead and write this down. Another example that you're going to have right there in your notes so that Mr. Lindsay can look back at it.
We don't have much room to start a new page.
Yeah, if you don't have a whole lot of room, you don't have enough room to put the whole thing on there, you might want to start on a separate page. We're gonna hurry up and get through this one, right? Because, like I said, there's like 5 or 6 two-column proofs on your homework. 3 of them are actually up here on the PowerPoint that you guys are gonna do for me here in a minute. So could Silas just write those answers down?
Yeah.
Then he doesn't have to do those at home. I know that probably breaks his heart. He'd rather do them on his own at his house, right, Silas?
No.
Before I even look at any of the given information on this, has anybody got a guess as to what you might use in this one at some point?
Reflection.
Reflexive property again. What?
LM.
Segment LM is congruent to what?
LM.
Segment LM, reflexive property. Those two triangles share that, right? You should, as soon as you see this, before you ever read even what the problem's asking you, you should realize that. Hey, both these triangles have segment LM in them. So probably somewhere through here, I'm going to use a reflexive property. Doesn't do much good if you can't see the picture. First thing they tell us, do I need to split these two triangles up?
No,
No, they're easily to
You can see the two separate ones probably, right? Segment KL is congruent to segment NL.
Yeah, that's true.
That's a pair of sides in our two triangles, right? So that's one part. We're a third of the way there. Segment KM is congruent to segment NM. That's another pair of sides. So we got a pair of sides, pair of sides.
And then
We need one more
there's
side, so-
reflexive property.
We need one more pair of sides, and what is it?
Reflexive property.
Reflexive property. LM is congruent to LM. Now, do we have enough to say the two triangles are congruent?
Yeah.
Yeah. And that's what we're trying to do, is say those two triangles are congruent, right? Before we start to write this, let's fill in this blank right here.
LMN.
Everybody agree with that?
Yeah.
No.
Let's-
It's L.
And
Let's look at it real quick.
Oh,
The easiest way to figure it out when you're looking at this, K falls in between the 1 mark and the 2 mark. What's the letter over there that falls between 1 and 2? So that means N's got to come first. L falls in between the 1 and the 3. So which one falls in between 1 and 3 over there? L. And then what's that mean M's going to have to match up to? What's our first statement going to be?
Second.
KL is
NL.
equivalent to
That was given. What do I put out here beside the 1? Is that enough to say the two triangles are congruent?
NL. No.
No. So where do I go to next?
KM is equal to NN.
Now notice when I'm doing this, do I just write all the given down very first thing? No, that's what a lot of you like to do. Don't do that, because sometimes you'll have to use that given information to lead you to other things, and then you just forget about it and you get lost. All right? This time, it worked out to where we didn't really need to use it for anything else, so put an S out here. How do we know it?
Given. And then what you put LM is,
Congruent to ML
the,
because anything includes itself.
no,
Alright, so what is it?
LM is equivalent to LN.
LM's congruent to LM. Don't turn it around, because if you turn around, that makes it look like it's different. Because we want it to be exactly the same thing. Wyatt's equal to Wyatt, not Wyatt's equal to Cisco or anything like that. It's got to be exactly the same. All right?
And anything is equal to itself.
Anything equals
Itself.
itself. Anything equals itself. What do I put out here beside the 3? Is that enough?
And then
What can I say?
triangle KLM is equal to NL.
Triangle what? And how do we know that? Side, side, side. S, S, S. Again, don't forget binders will be due here real soon.
I'm ready.
Think you can handle that, right? Alright, a stable figure. Just to let you know here, a stable figure. All a stable figure is a figure that has all the diagonals drawn in it. I'm not sure if this book's going to use anything about stable figures on down the road or not, so that's why I threw this in. So that all the smaller shapes are triangles. Not really, it doesn't matter. So in other words, if I gave you this pentagon, pentagon's not a stable figure, because if I built a box that was a pentagon and I took something and pushed on this corner, what would probably happen to it? It would smash, wouldn't it?
You can divide it into 3.
Now, if I divide it like this, put in some stabilizers there, now is it more stable? Yeah, when I go to push on it here, is it going to smash? No. And that's what it says. Look at the shapes that I formed when I drew in those diagonals. Triangles. When you take a shape and you split it into all triangles, that makes it a stable figure. That's why when you build a wall and you've got your studs all in here, is that what you do? You just leave it that way? No, you got to put in some kind of crossbar there to stabilize it. A lot of builders will actually even put, they'll put something like that in, and they may put something coming from the other direction, like on every other one or something, to stabilize it even a little more.
That makes it so difficult to put insulation in there.
Right, do what this says. Get out 2 sheets of paper. Get out 2 sheets of paper, write 249 that page and those problems down on the first one, 266 on the other one. Here in a second, you're going to do some 2-column proofs. So when we started, Sam wants to, on the first sheet, we're going to do a couple, and on the second sheet, we're going to do a couple. So Sam wants to have out that first sheet so that he can write down the answers to the ones that we had. Now Gunner, he doesn't want to write down the answers because he wants to do them all himself. Look at that, you counted 2. I'm proud of it.
Oh, thank you.
I think this is true. Let me ask you what your grade is right now. What? So I'd have to look it up and stuff.
What's up, Mom?
So.
What's up, Mom?
I can say that you returned your book, I just can't put a grade on here.
Yeah, I'm gonna have a perfect grade.
Yeah, that's probably not gonna happen.
I'm gonna say she just needed you to sign it, that way she can get that.
But just, if we get down there and they wanna throw a fit about it, I'll look on Google. It's on there, I just don't have I don't have time right now.
Because he's only been to school like 26 days. He sounds himself out. He's 18 this year.
Are we ready?
Hold on, no.
My dad used to have me skip school. Now it just don't happen anymore.
Oh.
This is problem number 15. Problem number 15. So write 15 down on the first page.
We're not doing like.
We're not doing it in order.
Yeah, we're
Yeah, that's all right. Just put this on the first page. It'll be all right.
If you really want to come all the way over.
Yeah. If it drives you that nuts, then write it down and get a new piece of paper later and fix it.
Just do like 2 on
Number 15. Look up here. We're going to go through this problem together. And then you're gonna come up and you can actually move these boxes,
We have to draw a sheet.
put it in. All I would do is write down number 15 and I would draw the shape. I wouldn't write down the given and all that stuff. You don't have to do that. Yeah, if you already got it, that's fine. It's not gonna kill you. Huh? That was so difficult.
It was.
Put the letters on there. So we have this. I'm going to think it through with you, and then we're going to go down the rows, and you're going to come up and put in each statement, each reason. All right? So the first thing, SP is congruent to TP. Is that a pair of sides in our two triangles? Yeah, so we have a pair of sides. Is that enough to say the two triangles are congruent? No. Then we say that segment PQ bisects angle SPT. What's it mean if that bisects that angle?
It's the point of it.
That's
No.
vertex.
So it's
Let's
Splits it into two congruent angles. So what two angles do we know are congruent here?
SPT.
SPQ and
Oh.
Angle SPQ, that's this angle. You gotta make sure you can name it with three letters, right? SPQ, and it's congruent to what? Heard like 6 different things. TPQ. Gotta make sure you go in the right order, right? T, P, then Q. That angle right there. So that's a pair of angles. Is that enough to say the two triangles are congruent? No, we got a pair of sides, pair of angles. We now need a what?
PQ is.
We need a pair of sides. Which sides does it have to be?
PQ is congruent to PQ.
PQ is congruent to itself. How did you know that?
Because
Reflexive property. Anything equals itself. Is that enough to say the two triangles are congruent?
No.
yeah.
Yes.
Yeah, by side angle, side. So should we be able to go through and prove these two triangles are congruent?
Yeah.
Now remember, what order did we go in? We proved these two sides, then we proved these two angles, then the two sides. Now the things are up there, all you gotta do is drag them over. When you drag them over, it's sort of hard to drag over, but you just gotta grab it and make sure you don't let go of it, and then drag it over. And put it in the right spot. So Natalie's gonna start us off, and we're just gonna go down the rows. So you better be paying attention. And you also should be doing what as you're
Writing down the answers.
writing it down?
If I could see it. Who's wrong? How about?
If it pulls up at, there you go. If it pulls up at a little box, then you gotta get sort of on the edge of it.
Is there
On
only
the
5
edge?
steps?
Got it.
Is there only 5
It's only 5 steps.
Is that okay?
Go!
Oh, wow.
You just blew it.
Supposed to do the
What?
statement.
You're just supposed to do the statement.
You only-
Way to go, Arden.
Oh, she was messing the rest of you guys up. Now you got harder stuff.
Wow.
Oh, we got this.
Really?
Ian, just move the given out and then put it back.
I thought you wanted the
I'm
whole
so smart.
thing.
So Ian's gonna do the next statement. Does everybody have that one written down?
Yes.
Sorry, guys.
That's the first thing, the given there.
I'm not sorry.
Ian's gonna do the next one.
Can I? Bam.
Give me a second.
Wait. Yeah, that's right. Wait.
Everybody agree with that?
Yes, please.
Is that the next thing you should have done?
Yeah.
Alright, so that works.
I can't really read that.
PG. S. PG. PQ. My bad. I can't see it.
When you click on the box,
Bisects.
be careful, Hunter.
SPG.
What? How'd you know what Ian put over there?
Oh yeah, you're right. Oh my god.
When you click on the box, try to click on the edge of the box, and that's how you drag it. You try to click in the middle of the box, it doesn't work.
Good.
What? Oh,
Now, once Gunner sees that that angle's being bisected, what's he gonna say next? What did we say next, Gunner?
I don't know.
Bobby,
Sorry.
we said that what was true? What'd you say? Stop for a second.
Yeah.
If an angle's being bisected, then
It's gonna equal itself. No?
if an angle's being bisected, what are you doing to it? Dividing it into two equal angles. So what would our next statement be? No, our next statement would be the angles.
Yeah, hold on.
Click and read.
So, I can't.
I don't know. Like, is that one?
SPQ,
Think
yes.
about,
Oh,
think
I thought
about
that-
what we just did. Okay.
Oh, my dear heavenly Jesus.
Off to the side. Hey, don't bring these.
Oh, Jesus.
Everybody agree with that?
I
No.
Angle SPQ is congruent to angle TPQ.
No, that's
That's right.
incorrect.
Yeah,
What?
That is right.
If you say this angle's being bisected, then next thing you're gonna say is,
Wait, that's
hey, these
triangle.
two angles gotta be,
That's triangle.
oh, that's triangles, that's not
That's
angles.
You had the right one first.
I couldn't see it from back here, it looked like angles.
I need my binoculars, honestly.
So Gunner's gotta know where do the triangles go.
You made that box.
That's it. Gonna be the very last thing, right?
Good job, Peter.
Now, how did Wyatt know what Gunner said?
He.
Stop writing.
Because of two angles.
An angle is
Intersected and split into two angles.
not just intersected, if it's
I
bisect.
can't read
If
it.
it's bisect, you shouldn't have to read it, you should know it.
Come on. There you go.
Can I go next?
That's so
No.
fun.
Yo, bro. Why does it
Yeah.
Yeah.
When you guys go up there, can you please click off the box? That's not right.
Wanna do it, Bob?
You had to give it.
Oh, wait.
Yeah, you're right, it is.
Segment PQs, congruent segment PQ, is that right?
Yeah.
And then how did Sam know what Silas said there? How did he know the PQ?
Anything equals.
The right side is so much better on the track. Like everything where it's supposed to be number one.
What's up with freeze? Reason?
Anything, what's it say, times itself?
Anything equals itself.
It's a nice thing.
Does it matter?
Are we waiting on something, Bobby? Christmas?
Yeah, I'm ready
Yeah,
for
I'm
Christmas.
aware.
So is that why we're sitting here doing nothing?
What time is Christmas break?
Can I just do both of them?
No.
Oh my.
Got grabbed, back up on the line.
Thursday winter, I thought it was already winter.
Really? Last time I checked, we were doing one.
Yeah, it's like 20 something is
So now we have enough information to say the two triangles, and our reason is,
Where's my knee? We gotta
Oh, no.
You deleted a letter. Hey, it's okay, we know what it is.
That's kind
Just draw an arrow. SAS.
S. Oh, I thought you were talking about.
No, you didn't think. No.
That one's small anyways.
It's okay. Everybody messes with it. Well, you're still-
Next one, do we wanna go on to the next one or not?
No, we're trying to use
That means you gotta do it yourself.
That's what
Alright. More homework than just a.
Make sure again, when you come in here next time, if you don't have the 2-column proofs, I know which ones are 2-column proofs, and I won't even say anything when I walk by Sam, and I look at his homework, I'll just either put a 0 or a check. I won't complain, I won't say anything.
Unless you're Bobby.
Then Sam will come in during intervention, why did you give me a 0 on that homework? And I'll say, because you didn't do the 2-column proofs.
What if you were
And that's what they do, 2-columns drawn and some of it.
I got busy day of night, but we just worked out.
So do I.
You still see that?
Yeah.
First problem we're going to do, piece of paper that's got page 249 on it. Keep it out. We're going to do problem 15, I believe it is. Yeah, you can just put that right at the top and be the first one on that page. So just find that page, recopy it. Problem 15. Looks like this. All I really want you to draw for problem 15, just draw this. Just draw the shape. So write down 15, draw the shape out here somewhere so you can mark it. On problem 15, we're going to think it through together. Then what I'm going to do is we're going to go down the rows right here, starting with Miles. Miles is going to put in the first statement. Then Colton's going to come up, he's going to put in the reason for Miles' statement. Then Maisel's going to put in the next statement. Nate's going to put in the reason for her statement. All these reasons and statements are little boxes over here. All you got to do is grab it like this. When you grab it on one of the edges, and you're just going to slide it over there. Does that make sense?
Mm-hmm.
Everybody can handle that?
Yeah.
Get off there. First thing they tell us, segment SP is congruent to segment TP. Are those two parts in our two triangles?
Yeah.
Yeah, a pair of sides. PQ, this ray or this line or this segment coming down through here, bisects angle SPT. What's that tell us is happening to that angle? It's being bisected. Splitting into two congruent angles, right?
So the two of them are congruent.
So what two angles are congruent?
Segment angle SPQ and angle QPT.
So everybody see that? This angle is congruent to this angle. You look down here, is that one of the things down here?
Mm-hmm.
Sort of hard to see, but yeah, I think it's right there. So now we have a pair of sides, we have a pair of angles. Is that enough to say the two triangles are congruent? We're out of given information. So we got to come up with something on our own. Anybody see anything? Segment PQ equals segment PQ. How do you know segment PQ equals segment PQ? Anything equals itself. Reflexive property again. Anything equals itself. Hey, that's one of the reasons down there. Once we know that, now do we have enough?
No. Sure.
Yes. So what do we know about these two
SAS.
triangles?
We know that.
So what's this last one right here, number 5, going to be?
SAS.
Side angle side. So we should be able to go through and drag our boxes over there, right, Miles? Miles is going to start us off again. Miles is going to do a statement. Then the next person's going to give his reason. And we're going to go down the rows. You got to sort of grab right on one of the lines. One of the pieces of the box.
You can't really do
Sort of hard.
first given, so you have to do the next one.
See how nice I am to you, Colton? You better do my homework today. If you like that easy one.
You can grab it. I broke it. There you go. No, just tap on it. Man, the thing's by.
You just gotta sort of tap on. Everybody agree with that?
Yeah.
First two right? Again, this is one of your problems, so make sure you write it down. Basil does the next one.
Okay,
Grab
alright.
an edge.
Grab it.
Yes.
Okay. Why do you have to come up here, Nate?
I'm doing it next.
Oh, I thought you might come up here trying to help me. I was like,
No.
only one person gets at a time. Okay.
Everybody tap on the board once, Nate. Everybody agree with those so far?
Yep.
Now, Colton's got a little harder thing. Once Basil put her statement up there, Colton's got to use her statement. So Colton knows, hey, if PC is bisecting that angle, then that's telling him something. Somebody help him out. What's it telling him?
That angle SPQ is congruent to QPT.
I didn't want them to tell you the complete answer. Colton, I just wanted them to tell you that the two angles have to be congruent, right?
Oh.
That'd be the statement, right? And the reason.
That'd be the statement. Now, you leave the reason alone. That's Jacob. Don't be trying to do Jacobs. I don't care how much money he paid you to do his.
I cannot even see this.
That's so small.
Scoot up. Go over and flip the light off for me.
Can I just like stand up here?
Yep. Now,
If angle is, oh,
Jacob is, click on the board, so there you go. If an angle is being bisected, it's being split into two equal angles, right? So Colton put the statement up there. Now you got to give the reason. How did Colton know that those two angles were congruent? And I just told you. Don't click on that one anyway. That's probably why he didn't like it.
I don't know. Yeah, what did Mr. Emerson just say?
What did I just say?
The big one. Yeah.
is it anything is bisected as bisected?
Says if an angle is bisected. So read it to him, Jacob. Listen.
If an angle is bisected, then split into two equal angles.
Two congruent angles, right?
Okay, it's supposed to be bisected.
No,
He
that's
just
not what
said
that's
that.
not what it says. He said read it. How you have it.
Why? What's mine say?
It says bisected.
I
that's
saw
not
somebody,
bisected.
so somebody, when I was doing with my other class, somebody must have.
Yeah.
Erased the key. Now, what's Kyle gonna do? Because he's out of given, can he just go to another given, piece of given information? No, it doesn't work, does it? Now, Kyle said that PQ equals PQ. How does Miranda know that PQ equals PQ? Miranda, how do you know that PQ equals PQ?
Oh my god. Can you fix that?
Next, what goes next?
That's it. Wait.
Triangle SPQ is congruent to triangle TPQ, and then SAS.
Do the rest of the assignment.
Where are they? Hey, maybe next year.
The next thing we know, segment PQ bisects angle SPT. So this angle right here is getting something done to it. What's it mean to bisect an angle? Splits it into two equal angles, right? So name the two angles. If this angle is being split into two equal angles, name the two angles that are equal.
STQ.
Slow down. SPQ, that's this angle right here. Everybody see that one? And TPQ. Are those angles in our two triangles?
Yes.
So that's a pair of angles. Is that enough to say the two triangles are congruent?
Now,
No.
can't we just do anything equals itself in the PQ?
Yeah.
So segment PQ is equal to what?
PQ.
Segment PQ,
Anything.
anything equals itself, right?
Yeah.
Yes. Sure. This should be like a
What?
36-hour session, shouldn't it? Is that enough to say the two triangles are congruent?
Side angle, side.
Side angle, side, right? So now, should we be able to go over here and do it? Yeah. And it shouldn't be we, it's going to be you. So we're going to start over there with Colin. Colin's going to go up there and he's going to put the first thing. Colin, all you got to do is you're going to grab this pin. Everybody else listening, you got to grab this pin. Grab towards like one of those edges. All right? So if Colin wants to grab that one right there, he's going to grab it and he's going to move it right over here in reason or statement 1 spot. Now we can probably figure out, is that going to go in statement 1? No. That's not good.
You broke it in.
Yeah, I messed it up.
That's awesome.
So when you're up here grabbing it, try not to tear up my
It's sensitive.
lovely stuff here. So Colin's going to go up there, he's going to grab the first statement, put it in its place.
I hope I have it.
I hope you do too. It's written on the board already.
Yeah, Tuesday.
I wasn't paying attention.
I don't remember the
All paying attention tonight.
He's cold on yourself, Colin.
I know I did.
Wow.
Hey. You don't have to push any buttons.
You're doing good, Cheddar.
Did you just call him Cheddar?
Oh,
He said cheddar.
He definitely said cheddar.
He said Cheddar. Colin, I'm gonna start calling you Cheddar, alright?
Okay.
Cheddar.
You gotta keep it on the board, Colin. You gotta move with it.
One swift motion.
Cheddar.
Is that right? Before it goes away? No, stay up there.
Is that the
Yeah,
Colin?
You gotta move it out of the way. It's not the right one.
He's gonna rush your last
You got that, Cheddar.
I'll go after him.
There you go.
Now don't go away because we still gotta figure out which one. Somebody help him out so that we're not here for the next 30 minutes. No, don't tell him the answer.
Give me the first one.
Look at the given information up there at the top. So what goes in that first statement?
This thing?
Exactly.
I had it right the first time. I grabbed it.
Nobody told you to put it down. You
He
want
broke it. He broke it.
He broke it.
PSA.
Broke it.
Colin, you gotta stand pushing at the board straight, not sideways.
He messed it up.
He did not just do that.
Yeah, he did. I started dying. Place cheese.
Grab it and move it over there, Colin.
One swift motion.
There you go.
There you go.
Next one. What should you be doing while you're sitting at your desk? You better be writing this down because this is one of your problems. Derek's going to go up there and he's going to give us a reason for Colin saying that segment SP was congruent to segment TP. Everybody see how Derek did that? Stay straight. You got to make a right angle with the board when you touch it. You can't be sideways like Colin was trying to do. Otherwise, it's going to keep letting go of it. Next one. Sam's going to go up there and he's going to do the next statement. You guys are all, this is all fun and games, but this is what's on that end of year test that you're going to have to do.
Wait.
Does everybody agree with that?
No.
Why not?
That's what we're trying to prove.
That's what we're trying to prove. Where should that come?
That's
That's gonna come very last thing, isn't it?
Get that out of there, Tiger.
You gotta grab it.
You gotta grab it like towards the corner.
There you go.
Given information. What is your given information?
Yeah, I see it.
Brother.
I'm looking for.
Give you my information.
There, go.
Does everybody agree with that?
Yes.
That should say, yeah, I guess it's up there. Can't see it from here. Blake B is gonna go up there next. She gets another easy one, right? How did Sam know his information?
It was
Given. Now we get to the harder stuff. So now Blake L's got a little tougher thing.
Up like out.
Hop up there and go. Look at what Blake, or look what Sam put in there. Read that to me. What did Sam put in there?
PQ bisects angle SPT.
So when you know an angle is being bisected, look at our picture up there. See the picture where I was marking everything at?
Yeah.
When that angle is being bisected, what's happening to an angle when it's being bisected? Somebody help him out. Don't tell him the answer, but what's happening to an angle when it's being bisected? Split into two equal angles. So what should you be looking for?
Two congruent angles.
Two congruent angles. You see anywhere where it's got two congruent angles? That looks like a triangle.
Oh, wait, never mind. Right here.
Yeah. How is your
No.
Click on it again. Click on it just on the board. There you go.
Alright.
Put it into the left corner.
No.
Left, your other left. There you go.
There. There we go.
I see you guys do all this stuff on the computer. You can't do it on my little whiteboard. Next.
That's not it. Is it not it?
Yeah, it is. That's it.
Pretty sure it is.
I thought.
Yeah, that's it.
Yeah, you're right. Select the.
Next,
smart
how
kids.
did Justin, how's Justin know that those two angles are congruent? Justin, do me a favor and move that side angle side down out of the way, because it looks like it's gonna be in your way.
Do what?
The SAS, move it down somewhere out of the way. There you go. Does everybody agree with that? Now Braden goes up there. We got a pair of sides, we got a pair of angles, but there is no more given information, is there? And we've already talked about the angles being bisected. So where did we come up with our third pair, or our other pair of sides from?
What do you mean?
Or what were the other pair of sides?
What do you mean?
What other sides did we say were congruent in that picture when we were going over it?
The being.
Oh, was that the one we said?
Maybe. Not to get over
Does everybody agree with that? Yeah. Blake, you're getting ready to go back up there if you can't be quiet and write this down and pay attention. Next, how did we know? Yeah, you. How did we know that those two segments were congruent? Anything equals itself. Anything equals itself. Next.
Yeah, okay.
Here we go.
Got a lot of pressure on you.
I know.
How did Logan know that?
Because it came next.
It's the last thing.
That's got to be the last thing. And since I showed you that there was only 5 statements and 5 reasons, the triangle's got to come last.
I really don't know the answer.
All right. Let's stand up there and just look silly for a while.
It's not wrong.
Click the board once so everybody can see that because the box is around it.
C, SAS is written
Because it's right up
It seems written to
You don't have that written down when you come in here next time. What kind of person are you?
No. Idiot.
Say it louder because I'm not allowed to say those words.
Big stupid
With an exception of K, 'cause he wasn't here.
That's true.
No, that counts. He was here. We started it.
You guys
He doesn't have
have
anything
to,
down.
you have to remind me that Kate wasn't here.
No.
Everybody got that one? Go up there and switch to the next one so we can move along.
Whoa, 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 whoa.
You better hurry.
I'm trying.
Switch it.
No, wait.
Alright, here.
Brady, you're slowing us up, buddy.
Number 16.
Number 16.
You can slow
Number
down.
16. Stop. Don't even do that. That drives me nuts.
What?
Stand right there for a second. Here, you can hold the pen. Because I'm going to talk it through real quick before we do it. Because if you don't think it through, before you start writing everything down, what you end up doing is you write down the given information, then what happens? Then you're lost after that, and you mess everything up. So on this, segment AB is congruent to CD. Is that a pair of sides in our two triangles? Yeah. Then we know that AB is parallel to CD. As soon as we know we have parallel lines, what should we look for?
Alternate interior.
Alternate interior angles. What do we know about those two angles right there? They're congruent. They're alternate interior angles. Alright? That's a pair of angles. Then, we're out of given information. Where do we go to next?
AC equals A.
AC is congruent to AC. Reflexive property, right? Anything equals itself. That was alternate interior angles right there. Is that enough to say those two triangles are congruent? Yeah. By what? Side angle side. Now, Miss Pease can do her first statement. Does everybody agree with that?
Don't get this wrong.
Let's hurry.
Good afternoon, National Trail High School. We have a few announcements for you. The first announcement, boys JV play at 6 o'clock tonight at South. So good luck to the boys basketball team.
Everybody agree with
Tomorrow, we have
that?
the freshmen JV and varsity basketball. They are traveling
Make sure
to
you're writing this down.
Brookville tomorrow.
We're gonna run out of
Freshmen
time.
play at 4:30. JV play at 6, and the varsity plays at 7:15. And also tomorrow, varsity wrestling team is at Arcan at 5:30. Also, staff, make sure you RSVP to Cindy if you are planning to attend our Christmas party. And I also want to say happy birthday to Sharice Hoplet. And that concludes announcements for today. So have a great day and go.
Easy.
Sorry, Cayman, I was mad at you.
I was here to get up.
I know you were. Go. I just want to take your easy. See, angles next, right?
Yeah, that's the only one.
Yeah, it's the only one with angles. Angle BAC. See, all this time here, I've been thinking you're not learning anything, Blake, and I've been wrong, haven't I?
Yeah, you have. Offset Calvin
Parallel lines. Then what do we know about the alternate interior angles? They're congruent. It's a good thing you put everything away, Colin. You could be writing this down instead of taking a 0 next time. Maybe a detention when I look and see that. Kaylee, can you do the rest of it for us? So segment AC is congruent to segment AC because anything equals itself. Then we know that, click the board. Then we know that the two triangles are congruent. And what's our reason for the two triangles being congruent? Side angle side. Now there's a whole bunch more that took off. There was one more on this that we were going to get. There's like 6 or so homework. I'll tell you what, I got this video going. If you get on here and you watch, alright, problem 15 on page 266. Problem 15 on 266. I'm looking at the given information here. Segment LM is congruent to segment JK. LM is this segment. JK is this segment. That's a pair of sides in our two triangles. Segment MJ is congruent to segment KL. That's a pair of sides in our two triangles. And then that's all the given information. We don't have any more given information, so I gotta come up with something on my own. I look over here, and the first thing I should have seen when I looked at this picture, looking at the diagram, is that the two triangles share segment JL there. So we know that segment JL, let's get rid of that, segment JL is congruent to segment J, is congruent to segment JL. And our reason is anything equals itself. Anything equals itself. So that's another pair of sides. So that's enough to say that the two triangles are congruent, and that's what we're trying to prove. So I should be able to go through and write this out as a 2-column proof. So I'm going to drag these over here. The first thing I'm going to drag over is the first given. Segment LM is congruent to segment JK. And we knew that because it was given to us. Can't really say a whole lot else about those two segments being congruent, so then I go to the next thing. It says segment MJ is congruent to segment KL. How'd I know that? It was given to us. That's all the given information, so now I gotta come up with something on our own. Well, the thing we came up with on our own was that segment JL was in both triangles. So segment JL is congruent to segment JL. And the way we knew that was the reflexive property, which says anything equals itself. I have a pair of sides, pair of sides, pair of sides. So that's enough to say that the two triangles are congruent. So that's going to be my next statement. And my reason for those two triangles being congruent, side, side, side.